Welcome to the 2018 AP Statistics FRQ exam. In this video, we're going to focus on question number 5 from that year, and we're going to fully explain the answers. It was a pretty basic problem, wasn't too difficult, dealt with some interpreting of histograms and understanding how data can be impacted by extra values and appropriate values, wrong values, and so forth. So I think it'll make it a lot of sense here. All right, so here was the question. The following histograms summarize the teaching year for the teachers at two high schools, A and B. So what they mean by the teaching year is what year of teaching is it for a specific teacher. So if somebody asks me, hey, what teaching year is this for you? I would say 20. It's my 20th year of teaching. All right, so they do tell that down at the very bottom. So they give the two histograms, on the left, school A, on the right, school B, and it says the teaching year is recorded as an integer, with first year teachers recording 1, as that's their first year, second year teachers recording 2, and so forth and so forth. Now, it tells us that the mean of both sets of data is 8.2. So maybe that's something we want to write down. So the mean for the A school is 8.2, and the mean for the B school is also 8.2. And they tell us that there were 200 teachers from school A and 221 teachers from school B. On the histograms, each interval represents possible integer values from the left endpoint up to but not including the right endpoint. So for example, if we look at this interval right here, that interval would be for teachers that are 4 up to 7 but not equal to 7. So that specific interval or bin would be for any teacher who's in their 4th, 5th, or 6th year. Again, it can only be integers, so it can't even have 6.5. But the 7, if you are a teacher who is teaching year 7, you would actually therefore be in this next bin. That would be for 7, 8, and 9. All right, so let's dive into the 3 questions stemming from this particular problem. So the first question says the median teaching year for one of the high school is 6, and the median teacher for the other high school is 7. Which high school has each median, and justify your answer. So one of the medians is 6 and one of the medians is 7, and we're supposed to figure out which is which. So to figure this out, there's 2 different ways you can actually do it. So the first does involve a little bit more work, but it makes complete sense. And it's not a lot of work by any means. So we have to understand that we don't have a formula for the median. The median is the middle value, but we do have a formula that could tell us the location of the median. And that is n plus 1 divided by 2. Now this, again, I'll repeat, does not tell you what the median is. It tells you the location in your data for the median. So for school A, if you recall, we had 200 teachers. So 200 plus 1 divided by 2. So that's obviously 201 divided by 2, which is 100.5. That does not mean the median is 100.5. It means that the location of the median is the 100. It's actually right in between the 100 and the 101st value, starting at the bottom. So what we could actually do is we could count to find this value. So in this first bin for 1 to 4, I would estimate, it looks like it's just over the 45 mark. So I'd estimate that that's about 46 teachers in that bin. The next bin from 4 to 7 looks like it's around 48 teachers, a little bit shy of 50. Now, if we add up 46 values in the first bin, 48 values in the second bin, that's 94 values. Again, we need to get to the 100th value, right in between 100 and 101. So when we go to this next bin here, which has about 24 people in it, now we're over top of the 100, right? And now 94 plus 24 is we're more than 100. So the point is the 100th teacher and the 101st teacher are both in this bin, and the median is going to be right in between them. So this bin is for 7, 8, and 9. So if I'm telling you that I know the median is somewhere in that bin, and one of the medians I have, the 2 medians are 6 and 7, well, it's obviously the 7. So for school A, they have the median for 7 because that's where the median value would fall in that bin for 7 up to 10. So that means it's got to be the 7. School A cannot be the 6 because 6 falls in this bin right here. Now let's actually prove that the median for school B could also be that 6, just to make sure. That's also pretty obvious. If we determine that school A is the 7, then school B has to be the 6, but let's still make sure we show it. Now they had 221 teachers, and we're going to add 1 and divide by 2. This gets me 222 divided by 2, 111. Again, the median is not 111, it's the 111th value. So in the first bin, from 1 to 4 years, we have about 79 teachers in that bin. And the next bin for 4 to 7, looks like we got, right around 44, 34. We're estimating that. Now, 79 plus 34 is 112. So we've actually already passed the 111th teacher, which means that in this bin is where that 111th teacher falls, and this bin is for 4, 5, and 6. So any value 4, 5, and 6 could be the median, but if we know one of the medians is 6, then that means that this has to be the 6. So hopefully that makes sense. Now, one more other way we can understand why the B is the 6 and the A is the 7 is because of skewness. They're both skewed to the right, but school B is more strongly skewed to the right. And when you're more strongly skewed to the right, the distance between your mean and your median increases. Now remember, they both have a mean of 8.2. The mean was actually something that they have in common. So since B is more strongly skewed to the right, the distance between the median and the mean is going to be bigger. So again, that means it has to be the 6, because the distance between 6 and 8.2 is more than the distance between 7 and 8.2. So they're both skewed, but B is more strongly skewed to the right. Now, everything I just explained, I kind of did with words talking out loud. Here is it all nice and typed up, so that you can feel free to take a pause and read this real quick. That way you can understand how I wrote and how I explained these two methods. Again, you don't have to have both of these. This is the first method I talked about, and here's the second method I talked about dealing with the skewness. All right, that's it for part A. Hopefully that wasn't too bad. All right, part B says an additional 18 teachers were not included with the data from the 200 teachers at school A. The mean teaching year of those 18 teachers is 2.5. So let's talk about what we already know. We already know that there were 200 teachers from school A, and their mean was 8.2. That's what we were given in the original problem. Now we have 18 additional teachers whose mean is 2.5 years. What is the mean teaching year for all 218 total teachers? Now, here's what a lot of kids do wrong. This is so wrong. They'll grab their calculator, and with the calculator, they'll do 8.2 plus 2.5, and they'll just divide that in half. Now the problem is that's wrong. Why is that wrong? Because that treats these two groups as equals. But these two groups are not equals. That 8.2 is weighted way more because it came from 200 teachers. The 18 is weighted way less because it only came from 18 teachers. So this is where we got to treat them fairly. Now think about how to find a mean, right? To find a mean, well, we have 218 teachers, so we need to figure out the total divided by 218. So we got to figure out the total divided by 218. Now, we don't know every teacher's individual value, but check this out. If we go to the 200 original teachers, we say, okay, I know that whatever the total for those teachers was, divided by 200 is 8.2. So if I multiply the 200 over, I get the total for those 200 teachers. So I'm going to take 8.2 times 200. Now, for these 18 teachers, once again, I don't know what each individual teacher was, but I do know that the total of those teachers divided by 18 equals 2.5. So if I multiply the 18 over, I get the total for those 18 teachers. And that's what I care about, is the grand total. So 8.2 times 200 is the total value of all the original 200 teachers. 2.5 times 18 is the total for the remaining extra 18 teachers that we added on. Add all of that together. That's our grand total, and then we can divide that by 218. So again, 8.2 times 200 plus 2.5 times 18. So that's my grand total. If I added up the years for every single teacher, divide that by 218, we get the new mean of 7.73. 7.73 is going to be our new mean. So hopefully that problem wasn't too bad after you understand about needing to get the totals. All right, last question here. The standard deviation of the teaching year for the 2021 teachers at high school B is 7.2. If one teacher is selected at random from high school B, what is the probability that the teaching year for the selected teacher will be within 1 standard deviation of the mean of 8.2? All right, now this is a pretty good problem actually. So let's kind of dive right into a little bit of a tricky one as well. But we already know that the mean for the 221 teachers at school B is 8.2. Again, that was given to us in the original problem. That was for school B. And we were just told that the standard deviation for those teachers is 7.2. And it says, if one teacher is selected at random from high school B, what is the probability the teaching year for the selected teacher will be within 1 standard deviation of the mean? Now, unfortunately, we cannot use the normal model. A lot of kids want to jump and say, oh, mean, standard deviation. Oh, I'm going to use normal model. I'm going to use normal CDF on my calculator. I'm going to find a z-score. Problem is I can't do that because, again, go back and look at the data. For school B, it was highly skewed to the right, definitely not normal. But I have to still figure this out, and I can still do it. It's not that bad because I have all the pieces I need. First, I need to be within 1 standard deviation of the mean. Okay, so if I take the mean and I add 1 standard deviation, that's 8.2 plus 7.2. Okay, we'll do the math. 8.2 plus 7.2 is 15.4. And then I'm going to go down 1 standard deviation. So again, going down 1 standard deviation would be 8.2 minus 7.2, and that lands me with exactly 1. Now, you cannot have a decimal number of years teaching. Remember, we did say it was an integer. You could have 15 years, but you can't have 15.4. So if I'm a teacher and I have 15 years of teaching, I have 15 years of teaching. So I'm actually going to change that to just a 15. So basically, the interval I'm looking at is 1 to 15. Any teacher that is from 1 to 15 years is going to be the type of teacher I'm looking for, right? So I have 218 total teachers. I need to figure out how many of them fall within that range of 1 to 15 years, which would be within 1 standard deviation. So now I'm actually going to go back to my histogram that we had from earlier. And here is that histogram for high school B. And I'm trying to look at how many total teachers were, again, from 1 to 15. So 1 would be all the way down here at the bottom. And then 15, now 15 falls into this bin. So now, remember, this bin is 16 and more. So I don't want that bin, right? So I'm going to stop right here. So basically, I'm looking from the very beginning, right? From the very beginning, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Again, this bin ends at 15. It does not include 16. So I'm basically going to count how many total teachers are in those first 5 bins, because those teachers would all be, again, within 1 standard deviation of the mean. How did I figure that out? I went down 1 standard deviation, I went up 1 standard deviation, I created this interval from 1 to 15. So now I just got to kind of estimate what's in each of these bins. So in this first bin, I believe we already said there's about 79 teachers. In this next bin, we got 34 teachers. In this next bin, we got, well, it looks to be about 28. Maybe we give a little bit of wiggle room there. Maybe somebody else would say 27, but about 28. In this next bin, we got 29 teachers. Looks to be just a little bit more than that, but still less than 30. In this final bin, it looks like we got just under 20, so let's say 19. So if we add up all of those, we get 189 total teachers out of the 218 that are in that range of 1 to 15 years, which means that they are within 1 standard deviation of the mean. So to find the probability, I simply have all of the 189 teachers that are successfully in that range out of my total 218, divide those, and we get 0.855. So the probability that a random teacher is selected and they are within 1 standard deviation, which means that they are teaching 1 to 15 years, then again, got 189 teachers that meet that qualification out of 218, divide, and we get, oh, not 218, I'm so sorry. I think I did the math right. Oh my gosh. Of course, I made a small mistake here. 221. I was crossing back to school A. I'm so sorry. But I believe my math is right. Let me double check real quick before you yell at me here. 189 divided by the 221 teachers in school B. Yes, 0.855. So I did have the decimal right. I just put the wrong number there at the bottom. So it's 221 teachers. So again, not too bad of a question, but a lot of kids I've noticed that have done this problem in the past, they want to jump and try to use the normal model or use z-scores. You can't because the data is not normal. It's clearly skewed to the right. So again, once we know the mean, once we know the standard deviation, All we want to do is go down 1, up 1, so that way we're within 1 standard deviation. Ignore the 15.4 because you can't have 15.4 years teaching. It clearly said it could only be an interval. So that's where we got 1 to 15. Then we looked at our chart and we added up all the bins that are for 1 to 15 years and divided by the total, and that's how we got the probability. So overall, not too bad. This problem was a pretty good one, and I don't think any of the 3 parts were overly difficult, but you do have to do a nice job showing your work and explaining. All right, that's it. See you later.